Very low density lipoprotein metabolism, or VLDL metabolism for short, involves the transport of endogenous lipids from the liver to the body tissues. It's perhaps one of the harder pathways you need to know, but it's high yield since it's tied to numerous diseases and drugs. But before we get started, I want to encourage you not to get lost in the details. Let the memory palace anchor you to the important steps, and you'll be more than fine. We'll start with a conceptual overview. Don't memorize this, just think about it. The blood is primarily composed of water, which means that lipids, which are hydrophobic, cannot dissolve in it. The body therefore needs an alternate way to transport lipids in the body, and to accomplish this, the body uses lipoproteins. Lipoproteins are fat transport particles. They have a hydrophobic interior, where they can store lipids, and a hydrophilic exterior, making them soluble in the blood. If you break down the word lipoprotein, lipo refers to lipid, and protein refers to protein. So, lipoproteins are just particles that are composed of both lipids and proteins. Easy, right? Now, the proteins they are themselves composed of are called apolipoproteins. So the word lipoprotein refers to the entire lipoprotein particle. The word apolipoprotein refers to distinct proteins within the lipoprotein. The prefix apo actually means away from or separate, so this makes sense. Still with me? Good. This video focuses on the metabolism of a specific lipoprotein, VLDL, which stands for very low density lipoprotein. VLDL metabolism is a pretty straightforward pathway, and I'll quickly go through the steps now. Don't worry about catching everything here though. We'll go through this in more detail throughout the rest of the video. VLDL synthesis takes place in the liver. First, apolipoprotein B100 is lipidated by the protein MTP. Once ApoB100 is loaded up with lipids, it is now a VLDL particle that can be released into the bloodstream. The VLDL then travels through the bloodstream until ApoC2 binds to the lipoprotein lipase. ApoC2 and the lipoprotein lipase together break down the triglycerides carried in the VLDL particle, thereby releasing free fatty acids to the tissues. The VLDL remnant that's left over is now known as IDL, which can be taken up by ApoE in the liver. Alternatively, IDL can be further metabolized by the enzyme hepatic lipase, which releases the remaining triglycerides, thereby forming LDL. Now that most of the triglycerides have been freed, the LDL particle is composed primarily of cholesterol. LDL's ApoB100 can then bind to LDL receptors, which facilitates endocytosis of the LDL particle and hence delivery of cholesterol to tissues. Now that we've discussed the overall picture of this pathway, let's discuss each step in a bit more detail. If you couldn't guess by the opening soundtrack of our video, our scene takes place in the middle of an extravagant wedding, replete with sumptuous food and even tastier drinks. And look at our beautiful bride. Wow, her wedding veil is absolutely gorgeous. Ugh, I'm tearing up. This wedding veil should help you anchor this scene to VLDL metabolism. Get it? A veil for VLDL. It's the VLDL veil. VLDL stands for very low density lipoprotein, and its main function is to transport triglycerides from the liver to the body tissues. VLDL has a very low density because it's composed primarily of low density triglycerides. Now, take a look at how our bride is handing out olive oil wedding favors. See, I told you this was a classy wedding. These olive oil wedding favors should help you remember that VLDL carries primarily endogenous triglycerides. Endogenous triglycerides are distinct from exogenous ones in that endogenous triglycerides are those synthesized by the liver. Exogenous triglycerides, on the other hand, are those that come from the diet. At Pixarize, we like to call triglycerides triglycerides, and olive oil is a fat that's almost always found in a glass container. So let these glass bottles filled with fatty oil remind you that VLDL carries endogenous triglycerides, or triglycerides. Next, take a look at the musical talent the newlyweds hired for the wedding. To celebrate their love, our musician is playing some music by blowing into the mouthpiece of his instrument. This mouthpiece actually stands for the microsomal triglyceride transfer protein, or MTP protein for short. Get it? A mouthpiece for MTP? It's the MTP mouthpiece. Next, notice the object in our musician's hand as he serenades the bride with his clarinet. Yep, You guessed it, it's a $100 bill. You know what they say, fancy weddings always come with big tips, right? Well, this $100 bill should help you remember apolipoprotein B100. Get it? A $100 bill for ApoB100 should be pretty easy to remember. The ApoB100 protein is the key structural protein in VLDL. In fact, there's only one ApoB100 protein per VLDL molecule. Now that we've introduced our symbols for MTP and ApoB100, let's talk about what they actually do. MTP stands for microsomal triglyceride transfer protein, and since it's a triglyceride transfer protein, it must transfer triglycerides to something, right? MTP transfers triglycerides and cholesterol to ApoB100, and this makes sense because remember, ApoB100 is VLDL's main structural protein. After lipidation, ApoB100 is now called VLDL, and the VLDL can be secreted from the liver into the circulation, where it will deliver endogenous triglycerides to the rest of the body. While we're here, I also want to briefly mention a disease affecting these steps. Mutation in MTP results in a disease, A-beta-lipoproteinemia, which is characterized by failure to lipidate ApoB100, and this causes ApoB100 to be rapidly degraded. The lack of beta-lipoproteins, or B-lipoproteins, is why A-beta is in the disease's name. A-beta-lipoproteinemia, this of course then results in a lack of VLDL, and therefore a lack of triglycerides in the body. For more information, check out our images on A-beta-lipoproteinemia and chylomicron metabolism. Next, let's talk about how triglycerides from VLDL are actually delivered to the rest of the body. Well, take a look at our chef here. He's using a butter knife to lather up some butter for the wedding guests. You see, our wedding guests really love bread, so our chef is toiling away to feed all the hungry guests. A good wedding has to have good catering, right? First, let the butter knife remind you of lipoprotein lipase. The butter represents lipids, and the knife cutting them represents lipase. Putting this together, the butter knife represents lipoprotein lipase, which cleaves triglycerides and releases individual fatty acids. Next, let the chef himself remind you of lipoprotein lipase's cofactor, ApoC2. Get it? A chef for ApoC? It's the ApoC chef. After being secreted by the liver, VLDL obtains ApoC2 from HDL in the circulation. ApoC2 on the VLDL particle can then bind to lipoprotein lipase. More specifically, ApoC2 is a cofactor for lipoprotein lipase, and together, they cleave and release triglycerides. The resulting free fatty acids can then be taken up by the body tissues. And by body tissues, I'm primarily talking about adipocytes for storage and muscle for utilization. Makes sense, right? Now that we've discussed how triglycerides are transferred to other parts of the body, let's briefly touch upon some diseases that occur in this particular context. Homozygous mutations in lipoprotein lipase or ApoC2 may cause a disease called familial hyperchylomicronemia, which you should also recognize as a type 1 hyperlipoproteinemia. On the other hand, heterozygous mutations in LPL and ApoC2 may cause familial hypertriglyceridemia, aka type 4 hyperlipoproteinemia. Familial hypertriglyceridemia is similar to familial hyperchylomicronemia, but more mild. Both diseases are characterized by high triglyceride levels, since lipoprotein lipase and ApoC2 can't break them down. For more information on these diseases, check out our images on chylomicron metabolism, familial hyperchylomicronemia, and familial hypertriglyceridemia. Okay, let's move on. Next, take a look at this statue or idol in the middle of the wedding hall. This idol is such a nice decorative piece. It must be a destination wedding. I've always wanted to get married somewhere exotic. Anyway, the idol is here to help you remember IDL, which stands for intermediate density lipoprotein. Get it? An idol for IDL. It's the IDL idol. You see, after LPL releases triglycerides from VLDL, the resulting VLDL remnant is now called IDL. The particle is now of intermediate density because we've lost some of those low-density triglycerides. IDL is therefore what's left over after most of the triglycerides have been removed from VLDL. This means that IDL is mostly comprised of cholesterol. See that fancy collar on our idol? This should help you remember that IDL is mainly cholesterol. It's the cholesterol collar. This being said, IDL does still contain some triglycerides, which we'll touch on in a moment. Next, take a look at the eel at the foot of the idol. Yep, this confirms it. We are definitely at a destination wedding. The eels really add an extra exotic aura to the ceremony. Anyway, this eel stands for ApoE. Eel for E, get it? As with ApoC2, VLDL obtained this ApoE from HDL particles already in the circulation. ApoE facilitates the uptake of IDL by the liver, making it an important protein that facilitates IDL clearance. Mutations in ApoE lead to a disease called familial dis-beta-lipoproteinemia, which you should recognize as type 3 hyperlipoproteinemia. For more information, check out our image on familial dis-beta-lipoproteinemia. Okay, let's move on to IDL processing. First, take a look at this liver pate knife. A wedding is never fully complete without liver pate. This liver pate knife should help you remember hepatic lipase. Liver pate for hepatic, and knife again for lipase. Get it? A liver pate knife for hepatic lipase? Remember how I told you that IDL still has some triglycerides in it? Well, that's what hepatic lipase is for. It's a lipase that cleaves off the rest of IDL's triglycerides. When the remaining triglycerides are removed, we are left with LDL, our final lipoprotein that we'll touch on shortly. Notice that IDL has two fates. 1, it could be taken up by the liver via ApoE, or 2, it could be further processed into LDL by hepatic lipase. This means that hepatic lipase serves as an important regulatory step in this pathway. Finally, notice how our fancy wedding attendee is ladling up some punch for a quick taste. That's not very hygienic, but okay, I guess it gets the job done. This ladle should help you remember our final lipoprotein, LDL, which is the final product of the VLDL metabolism pathway. Get it? A ladle for LDL. It's the LDL ladle. But oh no, it looks like the wedding guest spilled punch all over his fancy collar. As we mentioned before, the collar represents cholesterol, the cholesterol collar. LDL is rich in cholesterol, and its main function is to deliver endogenous cholesterol to the rest of the body. I'm going to repeat this again so you remember it. LDL delivers cholesterol, which is represented by the ladle spilling on the collar. While we're here, let's also touch upon LDL clearance. See the $100 bill in our wedding guest pocket? Oh, so he must have been the rich guy who tipped the musician. I knew that collar looked expensive. Anyway, let this $100 bill remind you that ApoB100 is responsible for the uptake of LDL. ApoB100 binds to LDL receptors on the liver and peripheral tissues, which mediates the endocytosis of LDL. And this is how LDL's cholesterol content is delivered. Yep, eaten right up. I also want to mention that LDL is implicated in atherosclerosis, which is why LDL cholesterol is commonly known as bad cholesterol. Since the LDL receptor is responsible for LDL clearance, in other words, the removal of bad cholesterol, is a target for a number of drugs. More specifically, PCSK9 inhibitors prevent the degradation of LDL receptors, hence leading to increased LDL clearance. There are also drugs that indirectly affect LDL receptor levels, such as statins. Statins inhibit cholesterol synthesis, which causes the upregulation of LDL receptors, so cells can get the cholesterol they need. Additionally, it's really important for you to recognize that mutations in ApoB100, or more importantly, mutations in the LDL receptor, can lead to the disease familial hypercholesterolemia, aka type 2 hyperlipoproteinemia. This disease is characterized by high levels of bad LDL cholesterol, which is where the disease gets its name. For more information, check out our image on familial hypercholesterolemia. Okay, I know that was a lot of material to go through. Let's do a quick recap so we can enjoy some liver pate at this fancy wedding. VLDL stands for very low density lipoprotein, and it delivers endogenous lipids throughout the body. It is synthesized by the liver, and its synthesis begins with MTP's lipidation of the structural protein ApoB100. The lipidated ApoB100 is now called VLDL, which can now be secreted into the bloodstream. Next, ApoC2 on the VLDL particle binds to lipoprotein lipase near body tissues. Together, they release triglycerides from VLDL and deliver them to tissues as free fatty acids. Once VLDL loses some of its triglycerides, it is now called IDL. IDL is either taken up by ApoE in the liver, or it is converted to LDL by hepatic lipase. The latter LDL is rich in cholesterol, and LDL's main function is to deliver endogenous cholesterol to the rest of the body. To do this, LDL's ApoB100 next binds to the LDL receptor. This facilitates the endocytosis of the LDL particle, and hence the delivery of its endogenous cholesterol contents. Okay, that's all for now on VLDL metabolism. I know this was a bit of a doozy, but this pathway is high yield. If you have a solid understanding here, you'll have no problem understanding the lipid-lowering drugs, the hyperlipoproteinemias, and the dreaded atherosclerosis. Okay, now go ahead and party with the bride and groom. You definitely deserve a study break.